how many of you plan to take a statistics course here at UCI? So Professor Utts teaches statistics, and she does teach some actually lower division classes, so you could actually end up in her classroom, which after today you will be very happy about, I'm pretty sure. So I'm going to pretty quickly turn this over to her. Professor Utts has been here at UCI for just 2 years, I think, after teaching at UC Davis for a long time. And at some point, years back, she got interested in statistical research on paranormal phenomenon. So I'm just going to let her tell you what she does. But let's welcome her. Thank you.
All right, thank you. Can you hear me okay? I'm not sure I need a microphone.
Can you hear the back?
Can you hear okay back there?
Yeah.
Yeah, okay. I could move it up a little bit. All right, so as Molly said, I've been here for 2 years at UCI in the Department of Statistics. Statistics is a relatively new department here at UCI, and we don't have an undergraduate major yet, but we do have an undergraduate minor. So if you're interested in statistics, you might consider that. It's a really nice complement to many majors, because just about every area uses statistics, as you may know if you've taken some statistics. So I have my webpage there and my email address, so feel free to, I'll put it at the end as well, because I do have some of my research papers on my website in case you want to read more. So I'm just going to do a few slides very broadly on what is statistical research, because I think part of the purpose of your summer program is to learn what faculty members do for research. My area of research is pretty unique. I'm probably the only person in the world that's doing it, but I wanted to give you a sense of what my colleagues do as well. So this is just quoted directly from our department webpage. Statistics is a science concerned with developing and studying methods for collecting, analyzing, interpreting, and presenting empirical data. Statistical principles and methods are important for addressing questions in public policy, medicine, industry, and virtually every branch of science. And so I would say that probably the lectures that you've already seen on people's research, almost all of them employ statistical methods and work with statisticians at one point or another on their research, because when they have data, as you all know, we're all different. And so the statistical methods help us sort out those differences and try and measure variability and quantify it in ways that then allow us to see if there's a difference in methods. For example, Elizabeth Loftus's research on false memories, not everybody has the same reaction to the kind of interventions that she uses. They use statistical methods to measure those differences. So what statisticians get to do for research? We get to work with researchers in virtually any academic area, help design studies, and help analyze the results. So the great thing about being a statistician is you can choose some area that you're interested in and go there. We develop new statistical methods when they're needed to do the research that other people are trying to do in their disciplines. So it's not all already cut and dried and in the textbooks. And then sometimes we work to combine and synthesize research results and then develop new research methods, and that's part of the research that I'll be talking about that I've been doing. So here's an example of my research that I'm going to spend most of the lecture talking about. And I just titled it From Psychic Claims to Science, Testing Psychic Phenomena with Statistics. So I'd like you to just broadly think, how do we know what we know? How do you think of something you really know is true? And then think about how you know that that's true. Now, normally when I ask people to do this, and if we had more time, I would have you tell me what you came up with. I find that people come up with things in two categories. One, private individual knowing. So you might have had an experience of something. You know that you love your parents, or you know that you love ice cream, somebody told me, that sort of thing. So you've had that experience. Sometimes people have faith or a gut feeling or intuition, and they're just sure that something is true because they have faith that it's true. Belief in experts. So some of the things that you think you know are true are because an expert told you that it's true and you trust them, you believe them. Things like the earth is round instead of flat, right? You probably have not had personal experience to verify that, but you believe people when they tell you that. The other way that we know things is our shared beliefs, our shared public knowledge. So we have shared experiences. We all know that gravity is real because we experience it together. Okay? Those who don't debate. Physical and biological laws, again, that we can verify through those kinds of scientific methods. But then the one that I want to talk about is studies based on statistical analysis. A lot of what we think we know is true is actually based on studies that were done on people or animals or whatever, and then analyzed using statistics. So, here's a bunch of synonyms for the thing that I study. Psi, PSI, it stands for a Greek letter, psi, which is the general symbol that's used in psychology. Psychic, that's a term you've probably all heard. ESP, for extrasensory perception, which covers something you've also heard. And then this term, anomalous cognition, or AC, was actually developed by some of the people that I work with to be a neutral term. So the term extrasensory perception implies that we have an extra sense. That may not be the case. So we want something that's neutral that doesn't imply a mechanism. So anomalous cognition means kind of funny thinking. Right? So basically what we mean by that is having information that could not be gained through the known senses. And we talk about different types of ways to do this. So telepathy would be information from another person. So let's say I had a deck of cards up here. Shuffle the deck, I pick a card, I look at it, I'm looking at it, I say, guess what the card is. That would be an example of a setup for telepathy, because you would be getting it from me. Clairvoyance, information from another place. So that would be I shuffle the deck, I choose a card, I put it up here on the desk, but I don't look at it. So nobody knows what it is, but I ask you to guess what it is. Precognition would be, I say, I'm about to shuffle the deck, tell me what card I'm going to pick. Hasn't happened yet. Okay? And there's another one that we've now started looking at. This one seems to be related to what we know about physics. And this is probably the best guess right now for what the mechanism might be for what I'm going to be telling you about. And that is somehow simultaneous access to information, action at a distance or knowledge at a distance, correlation between two events that can somehow be simultaneously accessed. If we're just trying to prove whether or not these things exist, it really doesn't matter which one of these is the mechanism. But if we want to understand it, then it does matter. And so a lot of the research that's done these days is aimed at trying to separate out what might be going on, which one of these might be going on. All right, so I'm going to start with a personal story. Well, not start, I've already started, but I'm going to give you a little personal story that indicates the problem with not using statistical methods or not using the scientific approach to studying this area. So is this a coincidence? Let's see what happens. I was visiting a friend when she received a call announcing a baby boy had been born to her brother and sister-in-law in Pennsylvania. I asked her what they had named him, and she said they didn't have a name yet. Two names popped into my head, Timothy and Michael, so strongly that I had to say something. So I said, if they named him Timothy or Michael, let me know, because these two names just popped into my head. A few days later, she told me they had indeed named the baby Timothy James. So I reminded her of my prediction, which she reluctantly acknowledged because she didn't want to believe any of this stuff. And she said, you were only half right. But then it turned out, in talking with her brother, that in fact Timothy and Michael were the two names they'd been trying to choose between. When I had said these two names popped into my head, Timothy and Michael. All right, so is that a coincidence, or did I actually gain information from Pennsylvania when I was out here in California? Well, let's look at, by chance alone, what's the probability that this would have happened? So suppose there are 100 reasonable names. I mean, in central Pennsylvania, you don't name your kid, Moonbeam. It's a reasonable name, right, that people would accept. So let's say there are 100 reasonable boys' names that you could have chosen, and I guess 2 of them are random. The probability that I would guess Timothy and Michael, so Timothy, if I just pulled a name out of a hat, 1 out of 100. Now there are 99 names left for the second one, I guess, so let's say 1 in a 99 for the second one. So the probability I would have said Timothy and Michael is 1 over 9900. But I could have said Michael and Timothy, another 1 out of 9900. So we're up to 2 out of 9900. But it would have been equally impressive if I had picked the 2 names to actually use. So if I had said Timothy and James, James and Timothy, that would have been equally impressive. And so the overall probability that I'm up to so far is 1 out of 2475. course, I didn't just pick these names out of a hat. So let's see how amazing this is. Well, turns out that that equates to about 6 years and 9 months if we talk about 1 over 2,475 in terms of days. So if I did something like this every day, I'd be right about once every 7 years by chance. So was I right by chance? Well, it seems unlikely, but asking that question is the wrong question. The proper question is, by chance alone, by chance alone, what's the probability of this particular unusual event? But rather, by chance alone, what's the probability of something unusual happening to each of us occasionally? And the answer is actually very high. So this is not good evidence for psychic functioning. In fact, I once did a calculation that if everybody in the world dreamt about a plane crash once in their life, then every night there would be something like 6,000 people dreaming about a plane crash. So the day that one happens, those 6,000 people suddenly think they have precognitive dreams. And you've got to remember there's, what, 6 billion people on the planet? 320 million in the US or something like that. So if something has a 1 in a million chance of happening in a given day, it's still going to happen to a lot of people in any given day. Okay, so this is not the way to go about verifying that this stuff is real. So how does science work to do something like this? Well, we have to go from anecdotes, of the type that I just gave you, to creating that shared knowledge that I talked about. So we create testable hypotheses. We design suitable experiments to test them. We analyze the results using statistics to see if they support the hypotheses. That might lead us to create new testable hypotheses, depending on what we get from the analysis. And eventually what we hope is that we accumulate sufficient statistical evidence and hopefully an explanation of how and why something works. Now, statistical evidence generally will just get you to whether or not there's something really there. The actual explanation for how it works sometimes requires looking at the brain or other kinds of scientific data. So how do we do controlled experiments to test psychic ability? Well, we need 2 crucial elements. The first one is, obviously, we have to rule out cheating and ordinary means of communication. So that's the first crucial element. Second one is, we have to know what should happen by chance alone. And in the Timothy Michael example I gave you, I didn't really have a very good sense of what should happen by chance alone. I took a wild guess. I mean, I was probably within a ballpark. But when we design experiments to test this, we have to design them so that we actually do know what would happen by chance if you were just guessing. So I'm going to give you a little quiz here. Is this okay? Does this meet the 2 criteria? I'm thinking of a number from 1 to 5. Guess it. See some heads shaking? No, that's right, it does not. It does not rule out ordinary means, because I could very subtly give you a clue up here. You know, I'm thinking of a number from 1, but I could very subtly give you a clue. Okay? And secondly, do people guess randomly? No. If I ask you to choose a number from 1 to 5, most of you will choose, the majority of you will probably choose 3. Very few of you will choose 1 or 5. We've actually done this with students in statistics classes. We say 1 to 10, and most people choose 7. The bulk of students choose 7. Almost nobody chooses 1 or 10. Okay. So it doesn't meet either one of these criteria. All right, now how about this one? My assistant upstairs, my office happens to be upstairs, my assistant upstairs has shuffled a deck of cards very well and picked one, and I want you to tell me what suit it is. Now, does that rule out cheating or ordinary means of communication? Pretty well, unless you have somehow set up in cahoots with my assistant to really bang on the wall, or you have a cell phone or whatever that's going to tell you. Okay, so that should do it. And also, the knowledge of probabilities of various outcomes by chance alone should also work, because the randomness is in what suit has been picked. So even if you always said hearts, there's a 1/4 chance that that's what would have been picked. So the randomness is not in what you respond. The randomness is in the way that my assistant has chosen the card. And you'll see that in the other research that I'll discuss, research that's actually done. Okay. So those are the 2 things we need. I'm going to talk about some research that's done in this area, and I'm going to show you how it meets these 2 criteria. All right, by the way, the 2 examples I just gave you are examples of what are called forced choice experiments. I'm going to show you the 2 different kinds. There are 2 basic types of experiments to test these abilities. First choice, that's like a multiple choice test. It's like what I just showed you. It's very easy to analyze statistically, but it's really no good. It's not a good way to test these things because there's what's called a signal-to-noise problem. Oops. Okay, so here's the signal-to-noise problem. If I say to you, there's a suit of cards, presumably you all know what cards are. There's 4 suits, hearts, diamonds, clubs, and spades. And if I say, I've just chosen a card, tell me what suit it is, what immediately pops into your head? All 4 suits, right? Because you have to know the choices. Well, now you have a big signal-to-noise problem. We know that if psychic abilities are real, they're not very strong. If they were strong, we'd all walk around being psychic every day and we would know it. So if there's a signal coming through somehow, it's weak, and you have a big signal-to-noise detection problem if you just thought of all 4 suits. If there's a weak signal coming through saying it's hearts or whatever, that's hard to pick up from the fact that you see all 4 suits in your head. If instead, I say to you, there's a photograph upstairs in my office, describe it. Just that's all I tell you. I might even say it's chosen from, well, like in one experiment, we used National Geographic magazine, had photographs from that. I might even say National Geographic magazine, there's a photograph, just describe it. You don't have the signal-to-noise problem anymore because you can't imagine every possible photograph that could be up there. So that's what's called a free response experiment. More like an essay exam. There are 2 main types that have been done over the years. One is called remote viewing. It was originally done by the U.S. government as part of a classified program. You may have heard that term. How many of you have heard that term now? Okay.
I've heard it from day spots.
From what?
Day spots.
Oh.
These are,
Yeah. Yeah, so this is a term that's actually out there now. As I'll say near the end, if you do a Google search on the term remote viewing, you get about 700,000 hits. Because it's just become part of the sort of vocabulary out there. But it was a term that was invented by researchers that worked for this classified program for the government, and I'm going to tell you quite a bit of history about that program so you can kind of see how this all developed. There's another kind of experiment called Ganzfeld, which is very similar. Ganzfeld is German for whole field. And you'll see why when I explain to you what Ganzfeld experiments are. The Ganzfeld technique was actually developed for other areas in psychology and then adapted for testing psychic abilities. So those are the 2 types of free response experiments that I'm mainly going to focus on. So let me give you a little bit of history and tell you how I got involved in this research. So as I said, the U.S. government had a program in remote viewing. It began in 1972. A physicist named Cal Putoff at the Stanford Research Institute, which is now called SRI, up in Menlo Park, California, did a $50,000 8-month project at the request of the CIA. And he invented the term remote viewing at that point. And it was convincing enough that the CIA decided to continue. So the following year, they had a program called SCAN-8, which stands for Scanning by Coordinate. And it was a test that they ran on a site that's still classified in West Virginia. Apparently it's an underground site. You can't see it if you fly over. Most people don't know it's there. And here's a quote from the report that was recently declassified about this. It said, "One subject drew a detailed map of the building and grounds layout. The other provided information about the interior, including code words. Data subsequently verified by sponsor sources." Sponsor meaning the CIA that sponsored it. I knew a little bit about this, and in fact, apparently what this did was triggered a huge security breach investigation because they couldn't imagine how anybody could know this stuff unless they'd broken into the facility, because it was so detailed. And yet, it was apparently just done by using remote viewing. In other words, not being there at all. There was a site in the Soviet Union that had equally good results, and the results were too good to be chanced. So the CIA got very interested. They also got worried because they heard that the Soviets were also doing this research. Turns out, not to quite be true, the guy who I'll talk about briefly here, named Ed May, who became the head of this project, is now writing a book with his Soviet counterpart, comparing notes and seeing what really went on during the Cold War in the 2 countries. Okay, continue. From 1973 to 75, more tests were done by the CIA and others, and Hal Putoff, along with Russell Targ and other physicists at SRI, who worked with him on this project, published a book called Mind Reach in 1977. And it talked about what they were doing, what they could talk about, and generated a lot of criticism from extreme skeptics. And SRI did not want that kind of publicity. SRI is a huge think tank. It has thousands of employees. This is one tiny piece of what it was doing. Did not want this kind of publicity, and so they said no more publicity. You can't publish anything. You can't talk about what you're doing. So it kind of went underground. During the next several years, 75 to 84, the Defense Intelligence Agency and others sponsored programs at SRI, some of the military and so on, into this. Then they began what's called operational work at Fort Meade, which is in Maryland, and most of that is still classified. What they meant by operational work is actually using psychics to spy. If any of you saw Men Who Stare at Goats, it's a little bit of an exaggeration of what went on in that movie, but they really did have a psychic spy program. They ramped up the research program from 1985 to 1990. This physicist that I mentioned, Ed May, took over as director, the one that's writing the book with his Soviet counterpart. And that's when I got involved. I was on my first sabbatical. I was at Stanford, and I met these guys. I was interested in what they were doing, and so I became a consultant to their program. Then I went and spent a couple of years there as a visiting scientist, working with them, trying to develop statistical methods and so on, and just watched this very fascinating research was conducted. And then I continued to be a consultant until the program ended, which I'll tell you about. So it continued. There was an increased research effort, as I said, during these years. It was sponsored by DIA and other government agencies. There was very high-level scientific oversight. We actually had really high-level government officials sitting there on site. We had this little program of 12 employees and this really high-level government oversight. And also an advisory board that was high-level scientists from a variety of areas to make sure that things were being done right. We focused on process questions. So how does this work? So we asked questions like, is a sender needed? And I'm going to show you how remote viewing works in a minute. The basic idea is, you have a photograph, as I said, that someone's trying to describe. So do you need someone looking at the photograph, actually trying to send the information? The answer turned out to be probably not. Does hypnosis help? If you hypnotize somebody and then say, do this, do they do better? Probably not. And is feedback needed? In other words, I tell you to describe a photograph, you do it. Do I need to eventually show you the photograph? The answer is probably yes. So that was all very intriguing and might suggest some of the ways that it works and the method. In the 1990s, in 1990, the research program moved to another think tank. So that was I'll just mention that because I'm going to talk about research done at SRI and SAIC. But continued with similar research, the entire staff moved over to this other think tank. The operational program at Fort Meade began to deteriorate. How many of you have seen Men Who Stare at Goats? Okay, just a few of you. Well, in that movie, you can kind of see it's much more extreme than what actually happened, but it actually did start to deteriorate in the sense that people were starting to do kind of new agey type things like lighting candles and invoking, things, etc. So the DIA really said, this is not, we don't want this program anymore. And, but there were some high-level people actually in the government and Congress that did want the program to continue. And so they tried to move it to the CIA. And so Congress actually voted in a line item budget to have the program reviewed because the CIA said, we only want it if it's useful for intelligence work because we're an intelligence agency. We don't care about the science as much. We want to know it's useful for intelligence. So Congress asked for it to be evaluated. And so they hired a think tank called the American Institutes for Research, who subsequently hired myself and a skeptic, a very strong skeptic named Ray Hyman, who's at the University of Oregon, and then their own staff were supposed to be part of the work as well. And this was called Stargate Review. The name of the code name for the last program that was done was Stargate, so that was the name that kind of caught on. We did our review over the summer, and again, I'll tell you more about that. And they didn't want us to release our results, but somebody leaked it to the media. And right around Thanksgiving 1995, ABC News Nightline ran a story that I was on. They had a former CIA director, Gates, who's now Secretary of Defense, Robert Gates. And then we were all on Larry King and so on. And we talked about this for about a week on television, and then it went away. And in fact, they terminated the program based on our review. Today, many of the former government remote viewers, the ones who were the so-called psychic spies, actually teach training classes What else is a retired remote viewer going to do? They've written books, some of them, and some of the past work that they've done actually does still remain classified and can't be talked about because it was about sensitive issues that the government still cares about. And as I said, if you Google the search now in remote viewing, you get more than 700,000 hits. So it's out there. So what is remote viewing? Okay, so here's how it works. This is what we did at SRI, and so thanks to Ed May, he put together this slide for presentations that he was doing. So basically, let's say at 10 a.m., there's a remote viewer or receiver, the term receiver is used, the person who's supposed to try to receive information, and a monitor who's supposed to be kind of like a coach. So if I said to you, you're going to do remote viewing, you wouldn't know what to do, right? So you would need someone to instruct you on what to do. So this person's in the room with you, sitting across from you. Of course, the monitor has no idea what the right answer is, because as I said, you can't have anybody in the room that knows the right answer. At SRI, they had a very strongly shielded room, so radio waves couldn't get through, somebody couldn't cheat, and give the information to the remote viewer by cheating. Okay, a little while later, after these people are sequestered in the room, an assistant doesn't use dice, actually uses a computer to randomly generate what's going to be called the target, the thing that's actually going to be the target picture that the remote viewer is going to try to draw. Chooses the picture. In this case, let's say we had a filing cabinet drawer full of lots of pictures. Choose the one that's going to be the right answer. Set it on the table. Let's say that's what it is, the Taj Mahal. Okay, then for 15 minutes of activity, this is what we hope happens. And that the remote viewer can therefore draw something at least that matches, at least somewhat, what the target material is. So that's how it works. Just some additional details. After the session, the drawings and the descriptions are copied and the originals are locked away so that they can't be altered. Because remember I mentioned that it's important to give feedback to the remote viewer. So feedback is given by showing them the Xerox copy, not the original, so they can't change it, along with what the actual target photo was. Now, sometimes, especially in later years, they started using short video clips instead of just photographs. They were richer, they have more information, and as you'll see, when I get to showing you how we judge these, it's okay to judge these. It's okay to use videos. It's not, because your first thought might be, well, yeah, if you show somebody a video, and you let them draw for 15 minutes, of course something in their drawing is going to match something in the video. Okay, well, and that's certainly true. So I'll tell you how we judge. In some labs, the viewer, the person who just did the remote viewer, is actually the judge, and feedback isn't given until after they've done the judging. In other labs, there's a separate independent judge, and again, I'm going to show you how the judging is done. So this meets condition number 1, which, if you remember, was safeguards to rule out cheating or ordinary means of communication. That's what we have so far. Okay, and we still have condition number 2 to worry about, which is that we have to know what can happen by chance alone. So, what is the target material? Well, in early experiments, right, I didn't say this yet, they actually used physical locations. So they had a whole set of physical locations in the Bay Area. One would randomly be picked, and someone would actually drive to that location and stare at this thing, and the remote viewer would be sitting in a room, supposed to try to draw where the person had gone. And they called that person the outbound experimenter. In later experiments, they used photographs. As I mentioned, in one experiment, we had a set of 200 National Geographic photographs that were used as the target pool, and I'll show you how the target was chosen from that. Short video clips are sometimes used. As I mentioned earlier, numbers, words, etc. are not used because of that signal-to-noise problem. So I'm going to show you, here's an excellent match. This was actually one of the guys who was one of the government remote viewers. He was really good. He still does this for a living. He has a consulting firm. He's written several books. His name is Joe McMonagle. I've put in yellow the writing just so you can see what it says because it's hard for you to read it. But it says key is a mountain, barn or large cabin, shadow of mountains, trees, road, etc. Path, American Rockies or maybe the Alps. So this is what he drew. And this was the target photograph. And I don't know about you, but I couldn't draw it that well if I was staring at it. So that's a really excellent remote viewing. And he had no idea, he just knew it was a National Geographic photograph. And this is what he drew. So that's really exceptional. We saw this kind of thing from this guy relatively often, but not every time. Okay, now here's a not, well, actually this is pretty good too, but this is an early remote viewing example. And this is, I want to use this one as an illustration of why we do the judging the way that we do it. Whoops, so there you go. That was the actual target. This was in the outbound days. So someone had actually driven to this place, okay? And the remote viewer who was back at the lab, this is what they drew. Okay, so single structure, I don't know how much of this you can read, anyway, dark browns and so on, boats, parking, it says parking over there on the side and so on. Okay, so this is what it was. Now, how do we judge this? Well, remember, this is the San Francisco Bay Area. So, of course, there could be water nearby for a lot of possible locations where you might go. You're sending someone to drive there, so it's a pretty good bet that there would be parking. Okay, so all these things, you know, we have no way to judge what should happen by chance alone, just looking at this. Here's how not to judge. I love this little, there was about a week where the Dilbert cartoon focused on Ken the Skeptic. So here's Ken the Skeptic talking to Dogbert. I alone know the contents of this envelope. Dogbert says, it's a charcoal drawing of a woodchuck eating a small orange. And Ken the Skeptic, nice try, you little fraud, but that's a long way from an ink drawing of a beaver eating a tangerine. So the issue here is, we can't use subjective probability of a match. There's too much room for personal bias. So Ken the Skeptic was not going to be convinced by anything unless it was 100%. So how do we judge? I'm going to have you try it. Here's a typical response from a novice, and again, I'll just show you the words here, you know, intersection, notch, groove, gap, wave, seawall, and so on. This is all the person drew. So you may see at the bottom it says EOS, that means end of session. So basically the way this works is, if I were the monitor and you were doing this, I would sit you in the room and I'd say, okay, pencil to paper, go. And immediately whatever came in your mind, you would draw and write words. And then when you thought you weren't getting any more information, you would say break. And then I'd say, do you want to try again? And you'd say yes or no. And if you said yes, you'd say, okay, go. And then you would draw again if you wanted to. And you could do this for, you know, maybe 15 minutes. But this person, this is all they drew. They said, I'm done, I'm not getting anything more. Okay, so this was, again, a novice. Okay, so we're going to use what's called rank order judging here. This is one of the ways that judging is done. And there's what the person drew. And here's 4 possibilities that it could have been. The judge's task is to rank these from 1 to 4, most likely to least likely to have actually been the target. Now that's not an easy task, you know. It says wave, there's a wave. That looks kind of like that. It says seawall, that's not a seawall, but it could be interpreted that way. That kind of looks like that. So your job is to pick 1, 2, 3, 4. Okay, so I'll show you what the judge did in this case. Okay, that's how the judge did it. And in fact, that was correct. One of the things that we learned over the years is not to trust words that people write. Images and shapes seem to be what comes through, not words. Now, one speculation is that this actually is a residual ability that we had when we needed it. You know, if you needed to know that a lion was about to attack you, you didn't need to hear any words. You needed to just get out of there. Okay? So you needed an image of danger or whatever. So that's one theory, is that in evolution, we don't need this anymore. So it's kind of atrophied, but that people used to need it. And shapes, images, and very low-level stuff is what comes through. We know immediately that if somebody starts describing things, they say, I see the Empire State Building, they're probably wrong. And so we say, well, what makes you think it's the Empire State Building? And then they can say, well, I see, you know, a tall spike and so on, and that's more reliable information. I once acted as a sender in a Gansfeld experiment, and the person that was the receiver, and I'll show you that experiment, but it's, sorry, the same setup where you have a receiver trying to describe something, and the person started talking about red and gold. And I just see red, and I see gold, and then the person said, it's the Kremlin. And in fact, that was the correct answer. But it was the red and the gold that was coming through, and then the person put it together and said it's the Kremlin because they associated those 2 colors with red square, gold, and Kremlin. So, how does this work? Well, an experiment has many sessions, and you just saw one example of a session. So before the experiment, the whole experiment is done, a target pool is created, which has many packs of 4 dissimilar sets of photos or 4 dissimilar short videos. And you've just seen an example of a target pack in those 4 photos that I showed you. Before a session, a pack of 4 is randomly selected, like the one I just showed you, and then within it, a target is randomly selected, in this case, the windmills. Then the session takes place, producing a response. And then after each session, a judge is given the response and the 4 choices from that target pack, like you just were, and the judge has to assign the 4 ranks. Of course, the judge has no idea what the right answer is. And then for each session, the statistical result that comes out is a single number. It's either the rank, the 1, 2, 3, 4, so in this case it would be a 1, because the windmill was ranked number 1. If the windmill had been ranked number 2, the number that came out of this would be a 2, a rank of 2. The correct target was ranked second, a 2. Or sometimes we don't, sorry, we don't use the ranks, we just say whether they got it right or not. We call that a direct hit. So either they got a direct hit or not. Okay. So, probability, getting back to our condition number 2. For a summary statistic for an entire experiment, which is many sessions, is either the sum of ranks or just the number of direct hits. And this meets condition number 2 because we know what the probability should be like. Okay? So for example, by chance alone, the probability of a direct hit is 1/4. And again, it's not because of what the person draws. People don't draw randomly. It's because that windmill picture had the same probability of being chosen as the other 3 pictures. And so there's a 1/4 chance that no matter what the person drew, that the judge would have been able to match it to the one that was actually randomly picked by the computer with probability 1/4. Okay, Ganzfeld. Very similar to remote viewing, except it's a little bit weirder. If you were in a Ganzfeld experiment, you would go into this situation, and I'll show you a picture of in a minute. So the target selection is the same as remote viewing. Random packs of 4, it's chosen randomly. There are packs of 4 photos or videos. The sender is in a sound-shielded room looking at a target. So there's generally a sender in a Ganzfeld experiment. So you would be, if you were the sender, you'd be sitting in a room looking at a TV screen, and either the photograph or the short video would come on the TV screen, and your job would be to try to send it to the receiver. The receiver, meanwhile, is in a sound isolation room, red light in their eyes, so it's really weird. They have kind of what looks like half ping pong balls over their eyes. There's a whole field of red light being shown at them. And that's where the name Ganzfeld comes from, whole field. They have earphones on where they're getting white noise, which is just like static, just random noise. And they're in a relaxed and comfortable chair. The idea is there's input coming in, their eyes are open, there's this white noise, but there's no signal coming in from their environment. So hopefully the signal that's coming from the sender in the other room will come in. That's the idea. They listen to a relaxation tape first, and then they talk into a microphone that's attached to them, attempting to describe what they think the target might be. And this is the experiment where I was a sender, and as I said, the person started describing and then mentioned the Kremlin, which is what I was staring at on my screen. There's a picture of what it's like. It's very bizarre. The experimenter and the sender both listen as the receiver talks. So I actually got to hear this person who was describing the red and the gold and then said the Kremlin. But of course they can't hear me. Then, when they're done with doing their description, the experimenter goes in. Of course, the sender can't go in yet because the sender knows the answer. The experimenter goes in, removes the ping pong balls. There's a TV screen in that room as well, and the 4 choices are shown to the person, and they have to try to guess which one they were trying to describe. So they do their own judging. And usually a direct hit analysis is used, so we just, over an experiment, count how many times people got it right. And by the way, when I say people, these experiments, unlike the government ones, where people had to be government employees because it was a classified program, these are just open experiments, and so the people who participated here were just people who were interested in doing it. And usually they didn't do more than 1 session, so that you couldn't have a magician come in and figure it out and so on. Although these labs were very carefully set up, magicians were actually brought in at the beginning to see if they could figure out a way to cheat. And so the loopholes were all closed. So here, the probability of a match by chance alone is 1/4 or 25%. Now, what constitutes evidence for statistical studies? Well, I was glad to see that a lot of you have had statistics. Even if you haven't, I'm going to just give you a very, very, very quick overview. So we create something called a p-value in statistics. A p-value is the probability of observing results as extreme as those observed, or more so, if chance alone is the explanation. So you can kind of think of it as odds against chance. So a small p-value means very unlikely to have happened by chance. It's not a direct interpretation. It's the other way around. So if chance was the explanation, how unlikely would these results be? So a very small probability means that chance probably isn't the explanation. So that's one way we look at data. Another way is to create what's called a confidence interval that we're pretty sure covers the truth. So in this case, what we would want is, we want to know what's the probability of a hit. And so we would create a confidence interval for that probability based on the data that we have. Another thing that we look for in science is independent replication. So we use something called meta-analysis, which is where we review a whole set of studies that have been done on the same topic to try to get an overall picture of what's going on. And we look for consistency across those studies. So the simplest model for remote viewing is we use directives and Ganzfeld, and the P is the probability of a correct match. Randomness and selection of target, I've mentioned that. So it's the P is the probability that the judge is able to pick the same target as randomization, given what the person said or drew. At chance alone is 0.4. So basically what we're looking for is whether or not we can verify that P is greater than 1/4 over many experiments. And if that's the case, it might indicate that some information is somehow being received by the receiver. Or, and with that term anomalous cognition, that something is true. So now we're going to go back to the review that I did for the government in 1995. Again, two-person team, myself and this skeptic Ray Hyman. We were asked two questions. Does psychic functioning work, and is it useful for intelligence work? We were sent 3 boxes of reports from the government work at SRI and SAIC. We were told to focus only on the government program, but because of what I just told you, I didn't listen. I expanded to include the Ganzfeld experiments because remote viewing work had all been done by the same people. And the hallmark in science is replication by independent researchers. If you can get different researchers all getting the same results, that's what you look for. Because if there's some subtle flaw in one person's experiment, you would hope that it's different in different experiments. So that's the hallmark of science. So here are the results I found. P-values and confidence intervals. For the government studies in remote viewing, at SRI they had 966 trials, a p-value of 4.3 times 10 to the minus 11. So that's the probability of getting results as extreme as we saw, or more so, by chance alone, if chance alone is the explanation. 34% hit rate, when we would expect 25% by chance. Confidence interval for the hit rate went from 31% to 37%, so well above the chance level of 25%. Same thing for the SAIC trials. And for the Ganzfeld results that I looked at them separately for each of the labs that particular summer that I knew were doing research in this area. Again, we only had 2 months to do the review, so I didn't do a comprehensive review of all the experiments that had ever been done. But actually, fortunately for me, there had been a meta-analysis already of a lot of that work, so I was able to use that at the beginning. So that meta-analysis had an 8% hit rate. And then you can see all the labs, if you look consistently down there, 34%, 37%, 33%, 33%. And all with relatively small values. So what I saw here was consistency across the government remote viewing work and the Ganzfeld work that was being done in a variety of labs. So what I said was, using the standards applied to any other area of science that uses statistics, I left that out, but that's what I was thinking because I'm a statistician. It's concluded that psychic functioning has been well established. Now, I didn't hedge this because I wasn't writing for a scientific journal, I was writing for Congress, and they wanted a yes or no. Okay? So that was my conclusion. And you can see my report on my website. And Ray Hyman wrote a separate report, by the way. What was supposed to happen is we were supposed to write a report and get to do a rebuttal to each other's reports. Well, he didn't do his on time, so he got my report first before he wrote his. So then he wrote his basically in response to mine, so then I got to do a rebuttal to his. So those are all on my website. Ray Hyman agreed that there was really strong statistical evidence, but he thought there must be a normal explanation. He couldn't provide one, but he thought there has to be a normal explanation. My conclusion was based on the results that I just showed you, plus the fact that I had visited most of those laboratories, so I knew that they were using sound procedures. How do statisticians integrate research from many studies? Well, we use meta-analysis, as I said, to combine the results. So I'm just going to show you very quickly what a meta-analysis is like, and then show you what it comes out like for the Gonspal. So this is a non-controversial example. As most of you probably know, taking aspirin is supposed to help prevent heart attacks. And there are millions of people taking aspirin these days because of this research. Okay? So how did that get established? Well, a meta-analysis of 25 clinical trials on the recurrence of heart attack or stroke with taking aspirin versus placebo looked at what's called, an odds ratio. An odds ratio is the odds of getting a heart attack taking aspirin compared to the odds of getting a heart attack taking a placebo. By chance, that would be 1. If aspirin doesn't work, placebo works equally well. It should be 1 to 1. There were 25 studies. Only 5 of them had a p-value less than a magic cutoff of 0.01. But the combined odds ratio was 0.75, indicating a 25% drop in the recurrence of heart attacks for people taking aspirin compared to taking placebo. So this is what we look at. We look at a whole bunch of confidence intervals, 1 for each of the 25 studies. And if you look, the line at chance there, there's all studies, the line at chance is an odds ratio of 1. And you can see that most of the studies actually overlap with chance. It's only when we combine all the data at the very bottom where the red arrow is that you can see that the results are different from chance. Okay, so any individual study is going to give you a wide range of possibilities because you don't have enough data to make a very strong, firm, precise conclusion. But combining the data gives you that strong, firm, precise conclusion that you see at the bottom there. So now let me show you that for the Gonspal experiments. I looked at 58 studies from a variety of labs. There were 728 hits total in 2,206 trials, a 33% hit rate. 95% confidence interval was 0.31 to 0.35. P-value of 6.2 times 10 to the minus 17. So pretty unlikely by chance alone what's going on. And here's a similar picture to the one with the aspirin studies. And again, you can see that the line at chance, which in this case is 25% hit rate, many of the studies overlap with chance. But when you combine all the data, you get that little interval down there, which is nowhere near the chance value of 0.25, but instead is centered on 0.33. So what it looks like to me is that we would expect people to get the right answer 25% of the time by chance. Instead, they're getting it right about 33% of the time, about a third of the time. Oops, that was chance. Okay, now let's compare this to the aspirin studies. Well, first of all, the aspirin trials were very heterogeneous, including a range of ages, a range of different diseases, a range of treatments, and so on. I bring this up because if you do look at the reports on my website, you'll see that one of Ray Hyman's criticisms was, wait, you're comparing apples and oranges, comparing remote viewing and Gonspal. Well, that's what they did here too. Very heterogeneous set of studies. This was a quote, another criticism of the parapsychology or the science experiments is that you don't always get statistically significant results. Same was true here. I won't read that quote, it's kind of long. But it's easy to not get statistical significance if you have a small study. That's always true everywhere. Here's something that would never fly in parapsychology. It says the main results were obtained from principal investigators in most cases, but in some trials the data obtained differed slightly from the data originally published. Very sloppy, okay? Never get away with that in parapsychology. People talk about parapsychology experiments being done by people with a vested interest. Okay, there's pretty much vested interest for the aspirin studies. They were sponsored by Bayer Aspirin, the Aspirin Foundation, etc., pharmaceutical companies. Okay? And finally, you would never get away with something like this in parapsychology because what would stop people from having their pill analyzed to see if it's aspirin or placebo? You could never get away with that kind of little possible loophole in the experiment in parapsychology. You have to be extremely careful that there's no possible loopholes, no other possible explanation. So let's compare. How are they different? Well, first of all, if the same standard is applied, the anomalous cognition results are actually stronger than the aspirin heart attack results. The aspirin studies had more opportunity for fraud and experimenter effects. The aspirin studies were at least as frequently funded by those with a vested interest, conducted by those with a vested interest. Both used heterogeneous methods and participants. So here's my question to you. why do people believe the aspirin results, but you probably didn't even know about these anomalous cognition results? And people who do know about them have a hard time believing them. Why is that the case? Well, let's go back to establishing scientific knowledge. How do we know what we know? I would bet that most of you, when I asked you at the beginning to come up with something you really know is true, most of you came up with something you know by experience. Not that someone else told you that it's true. So personal experience, I think, and personal beliefs play a very large role in what we think we know. And I'll ask you another question. Would you be more convinced if I showed you lots more statistics, or would you be more convinced if you had one overwhelming personal experience? And again, I would bet it would be the overwhelming personal experience, even though I can tell you that coincidences should happen to you once in a while. But people are much more convinced by personal experience. So one of the areas I'm doing research in now is using what's called Bayesian statistics to analyze results. Bayesian statistics is a general area in statistics where we combine people's prior beliefs with the data and then see what we come up with. And it's very interesting if you do that in this area, because you'll see that if someone has really narrow prior beliefs, so they're really pretty sure that this can't be real, then it would take a huge amount of data, if at all, to convince them otherwise. If people are open-minded and they look at data, then they're actually more easily shifted in what they think. And that's true, of course, in anything, in politics, in other areas where people have strong beliefs. Okay, just a little bit more about my current research, since that's the theme here on this series. I'm looking at, with some other researchers, at a meta-analysis of another type of psi experiment called presentiment, which is really cool because it gets the brain out of the way. What it does is we hook you up to a monitor that monitors your physiological processes, like the galvanic skin response on your finger. And then we show you a picture on a computer screen that's either neutral or scary or some other way would elicit a response. Now, if we just showed you that picture, your skin would jump, okay? We would see it. We would see where we showed you that picture. If we showed you a neutral picture, you'd have a slight reaction, but not nearly like you would for the scary picture, a snake with its mouth open at you, that sort of thing. The interesting thing about these experiments is we measure people's physiology just before they see the picture, and we find that people are responding. So we're doing a meta-analysis of a bunch of studies. There have been about 40 studies now on this, and we're doing that. I'm also working with some people looking at possible models that would fit in with what we know about physics. There's a lot of really interesting stuff going on in physics these days, some of which would actually fit nicely with the data that we've seen in this area. And just to end on what statisticians do for research, I'm also doing some other research in other areas. I'm still working with people at UC Davis in the medical school there, investigating EEG sleep patterns, so we hook people up to monitors to the brain, and menopause, looking at how sleep patterns change when we go through menopause. My other big area of research is statistics education, and so I'm doing quite a bit with that. I've written some textbooks, and I'm a big advocate of teaching statistics differently than we do to help people understand what they read in the news rather than have to compute formulas. So that's another big area of my interest. Okay, I don't know if we have time for questions or not, but there's my contact info. If we don't hear, we can send an email or on the website. We do have time for a few questions, okay? All right.
Are there any questions?
Are there questions?
Is remote viewing the same thing as technical remote viewing?
There are a lot of, the question is remote viewing the same thing as technical remote viewing? There are a lot of terms that have been developed by people that are now teaching this stuff, and so that's probably one form. So people have different ways of teaching it that they think work best. So people have come up with different things like associative remote viewing, coordinate remote viewing, and so on. So I don't know exactly what that means, but it sounds really good that somebody's come up with that for their method of doing it.
Is there a wide range of ability in this area, and how does that?
Right. Is there a wide range of ability in this area? I think so. I think there probably is. When I was working on the government program, we actually tested people because we tested people en masse. So we would have a large auditorium with government employees or SRI employees, people that already had clearances because of the classification, the classified program. And we had people all try to draw a target, and then we would show them the answer, and we did see quite a range, but of course that's not a really good way to judge whether there's a range of ability. We did find some talented people that way, though. And just in general, from what I've seen, I think there is quite a range. And I don't know, though, if it's because some people won't allow it to happen, or because there actually is a natural innate ability like there is for playing the violin or anything else, any other ability that we have, hand-eye coordination and so on.
So in your experiments, were you looking for people with extraordinary ability?
Were we looking for people with extraordinary ability in our experiments? Only when we did this kind of screening, when we were looking for new people to participate. So in the government research, we purposely wanted to find people who could do it and were good at it because we wanted to test these other kinds of hypotheses, like does hypnosis work, is a sender necessary, and so on. And if you have people who can't even do it, then you can't test those kinds of things. On the other hand, in the other laboratories, the kind of open laboratories, they don't want repeat customers because they want to just basically see if people in the general population can do it, and they don't want people saying, oh, you know, I was certified by such and such laboratory as being psychic and that sort of thing. So there they don't look for people. Although there have been a few experiments using certain types of people. So there was a Ganzfeld experiment done early on with students from the Juilliard School of Music in New York City. And unlike the general population that had like a 33% hit rate, that population had a 50% hit rate. And that was replicated in Edinburgh, Scotland, with students there who were in the in the arts, and they also had a much higher hit rate than the general student population. Yes.
Did the hit rates remain constant, or did they vary?
Did the hit rates remain constant, or did they vary? They remained constant over the laboratories, like I showed you there. So that was kind of interesting. Of course, different people had different abilities, but yeah.
The people who were in the study more long term, did they improve, or did that rate remain the same?
Unfortunately, they did not improve. Does not seem to be something that, well, there's a little bit of improvement you can get just by teaching people to not focus on, like I said, the higher level stuff like naming the Empire State Building. So you can teach people what to kind of watch for, what you're really trying to get are symbols, colors, shapes, that kind of thing. But once you get over that basic level of teaching them what to do, it doesn't seem that they can improve beyond that.
Was there an age limit, the people who were, more accurate, were they younger, were they older?
Was there an age limit? Unfortunately, we could not find anything like that seemed to correlate with how people did. We gave them psychological tests, we even did some brain scans at one point, and there didn't seem to be any way to predict or correlate any kind of anything like that. So age didn't seem to happen. Didn't seem to matter.
What physical mechanism could be allowing this?
What physical mechanism could be allowing it? My best guess is we don't understand space and time, and that there is some probabilities of different futures, and some are more likely than others, and that this could never be 100% accurate because we can't. Future is not 100% set, but just like in quantum states, there are certain quantum states that once the observer observes, it's determined, the state is determined. But before that, there are probabilities of different states, and some are higher than others. So my best guess is it's something like that. Another guess is that we actually live in like a 10-dimensional world, like string theory would predict. And somehow if you can get out of our 3-dimensional world, you can get this stuff somehow. Those kinds of ideas. Yes?
You said you've done MRI scans or doing this? Is there any?
There have been some MRI experiments, yeah.
Is there a specific brain region that lights up when it's different?
No specific brain region. Again, another frustration. Right. Now, one thing is, it's not even clear that you can get someone to do the process in real time. So this guy, Joe McMonagle, that I mentioned, who's been on lots of TV shows because he's so good at this, he tells me that he actually usually does it in his hotel room the night before and then just replicates it on the TV show. So, I don't know.
Is that kind of like parallel universes?
Parallel universes, that's another theory that physicists have come up with, yeah. So who knows? What we do know is physics is weirder than we think, right? The physicists are telling us that the world is a lot weirder than we think. There's a quote from a famous physicist, I can't remember which one, that says, anyone who tells you they understand quantum mechanics is lying. Because it's inconceivable, what we're finding in quantum mechanics. So I know I really think that someday we'll have a so-called normal explanation for this. I really think it will fit in with our laws of physics, so we don't need some sort of new agey weird stuff to explain it.
Kind of going back to the same question. So is the image more random in each different imaging? So in other words, the other person that you image or the other person that you image have more diverse brain activity in different areas? Since it's not
Yeah, I don't know enough about the MRI research that's been done. I just do know that they have not been able to kind of pinpoint this is where remote viewing is happening.
Any approximate number on how many studies have been done, like order of magnitude, 10, 100, 1,000?
It depends on what topic you're talking about. There was just a new meta-analysis done on, updated meta-analysis on Gon's health studies just published this summer. So it's not included in what I just showed you. But it really depends on the area. These pre-sentiment experiments that I'm talking about, there have been about 40 in the meta-analysis we're doing. We collected all those studies. So it depends on which domain, but it's not huge. There are almost no studies going on these days in the United States. Most of them are being done now in Europe. The United Kingdom has a very active research program compared to us. There are maybe 19 universities in the UK where you can actually study this. There's a very active debunker group in the United States that pretty much wiped out the research in this country, unfortunately. And so it really has, the shift has moved over to Europe. But it's not huge. There just aren't that many laboratories doing this work. I would say maybe at this point, 10 active laboratories. So the universities in the UK, they're not all actively doing laboratory research, but they are teaching stuff. So it's not huge. So, because one explanation people try to come up with is, well, there's a huge, what's called a file drawer. In other words, there's all these studies that are being done that aren't published, and only the successful ones are being published. And that's why you're seeing these strong results. But that doesn't explain it in this case, because the researchers all know each other. The professional organization called the Parapsychological Association only has about 200 to 300 members. So they all kind of know each other. So it's not like doing research in biology or something like that, where there's tens of thousands of people doing it. Any questions?